Let us see depth buffer method or set buffer method. This is an image space approach. That is, visibility is decided point by point at each pixel position on the projection plane. It is implemented in screen coordinate system. In this figure, x-axis is this one, y-axis and z-axis. And xy, the point of coordinate xy is represented in the xy plane. These all are various surfaces. It's first one, second one, third one, and four surfaces are drawn here. Whenever you have more than one surfaces like this, you need to find out z value of each surface and find out which surface is nearer. If there are n number of surfaces, you need to find out all the z values. Z value means the distance from here to this point. Here, positive z-axis is represented here and negative z-axis and xy plane. Suppose if you are sitting in the positive z direction and viewing this plane, these surfaces in which are in negative z direction, and you can see that larger z values, this is having larger z values, that one is closer to you, and smaller z, the surface is having smaller z value, this one will be farther. On the other case, suppose if you are sitting in the negative z direction here and viewing plane on the positive z direction, what will be the difference? The smaller z value are closer to the viewer or you, and larger z value are farther to you. Here we are starting with the pixel position of view plane and for particular surface of object. That is like this. If we take orthographic projection of any point xyz of the surface on the view plane, we get two-dimensional coordinate xy for that point to display. Here we are taking xy position on plane and find particular surfaces at how much depth. That is from here to here, then from here to here, like this. We can implement a depth buffer algorithm in normalized coordinates so that z values range from 0 at the back clipping plane to z max at the front clipping plane. Here z maximum value will be 1. So z value is in between 0 and 1. In this algorithm, two buffers are used. One is depth buffer and another is refresh buffer. Depth buffer is used to store the depth value of each xy position, that is z value. And refresh buffer is used to store the intensity values. Initially, depth buffer value is 0. Set depth buffer value as 0. And refresh buffer value as intensity of the background. And each surface of polygon is then processed one by one, scan line at a time. We have to process this one, each surface of polygon. Calculate the z values at each xy pixel position. We have to calculate all the z values. If calculated depth value is greater than the value stored in the depth buffer, that is initially we have stored the depth buffer as 0. In the first case, if it is calculated z values, depth value is greater than 0, then replace that new value to the depth buffer and store the intensity of that point into refresh buffer at xy position. And here how to calculate the depth value. Depth values are calculated from plane equation. We know the plane equation as x plus by plus z plus d is equal to 0. Then we have to calculate this z value. So from this equation we can calculate cz as minus x minus by minus d. Then take the z. Z is equal to minus x minus by minus d by c. Then from this figure, this is xy, this point is xy. Then horizontally next one is x, the coordinate is x plus 1 y. And in the point below this one scan line, below the scan line is x y minus 1. And here from the position xy on the scan line, the next position across the line has coordinates x plus 1 y. And the position immediately below on the next line has coordinates x y minus 1. For horizontal line, next pixel z value can be calculated by putting s dash is equal to x plus 1 in the above equation, this equation. So I will get z dash is equal to minus a into x plus 1 minus by minus d by c. That is equal to minus ax minus by minus d minus a by c. So we will get z of x plus 1 or z dash is equal to z minus a by c. Similarly, for vertical line, pixel below the current pixel has y dash is equal to y minus 1. So its z value can be calculated as z dash is equal to minus x minus by. Instead of y, we are representing y minus 1. Minus b of y minus 1 minus d by c. So we will get it as minus x minus by minus d plus b whole divided by c. So z dash is equal to z plus b by c. If we remove top to bottom of polygon boundary, we will get x dash is equal to x minus 1 by m and y dash is equal to y minus 1. How we will get x dash is equal to x minus 1 by m? Here we know y minus y dash divided by s minus s dash is equal to m. From here, put y dash is equal to y minus 1. So we will get y minus 1 divided by s minus s dash is equal to m. So 1 by s minus s dash is equal to m. From that, s dash is equal to x minus 1 by m. Then z values is z of y minus 1 or z dash is equal to z plus a by m plus b by c. Same thing is repeated here. Finding out the z value. Here the point is x y, s plus 1 y and x y minus 1. From this equation, s minus s plus b y plus c z plus d is equal to 0, z is equal to minus s minus b y minus d by c. We have to calculate zh plus 1 and zy minus 1. Zh plus 1 is equal to minus a into s plus 1 minus by minus d by c. That is zh plus 1 is equal to z minus a by c. Then we have y minus y dash is equal to y dash divided by s minus s dash is equal to m. Here y dash is equal to y minus 1. So y minus 1 by s minus s dash is equal to m. So you will get s dash is equal to s minus 1 by m. Then in order to calculate z y minus 1 minus a s dash minus b y dash minus d by c, then we are putting s dash is equal to s minus 1 by m and y dash is equal to y minus 1. So we will get z of y minus 1 is equal to minus a into s minus 1 by m minus b into y minus 1 minus d by c. So minus as minus by minus d by c plus a by m plus b by c. So algorithm is this one. First step, initialize the Z buffer and frame buffer, so that for all buffer positions Z buffer of xy is equal to 0. Initial case Z buffer value is 0 and frame buffer value of xy is equal to background, intensity of background, that is represented as I background. Then second step, during scan conversion process for each position on each polygon surface, compare depth values to previously stored values in the depth buffer to determine visibility. Then calculate a Z value for each xy position on the polygon. If Z greater than Z buffer of xy, what we have already stored in the Z buffer, then set Z buffer of xy is equal to Z, newly calculated value, and frame buffer of xy is equal to intensity surface of that xy. Then third one is stop. Third step is stop. Then advantage of using this Z buffer algorithm is it is easy to implement and it can be implemented in hardware to overcome the speed problem. Since the algorithm processes object one at a time, the total number of polygons in a picture can be arbitrarily large. And here are the disadvantages. It requires an additional buffer. Thus we are using two buffers and hence the uses the large memory, and it's a time consuming process as it requires comparison for each pixel. We are comparing each pixel instead of for the entire polygon. That is the disadvantage. So thank you.